Uh, so, uh, wow, we're looking a little light at the back end of the room there. So, um, all right. Well, let's start with just a couple pieces of a business update. So, um, we've got what, roughly 6 weeks left of classes before finals, roughly. Uh, I think no, I think well, it's okay. The counting is funny because we started on a Wednesday, so I think 6 weeks started like today or Wednesday, something like that, right? So anyway, we got about 6 weeks to go. So we're going to be transitioning to a very project-heavy part of the semester rather than more of the traditional, what we've been doing, which is sort of math class style. Uh, so what? So we're going to do sort of a series of uh, kind of some smaller projects, some slightly bigger projects over the next 6 weeks, basically until the end. The other thing that we're going to have is, well, you guys haven't had an exam yet, right? Well, it's time for us to do something. So we'll do that uh, electronically, not in class, starting next week. And the way that this will work is I'll unlock it on Canvas at one time, and then it's due at a different time, and you just find some time to sit down and do it. Um, and the way it'll work is uh, in the subsequent weeks, you can retake it if you're not happy with how you did. Okay, so I mean, it won't be the same questions when you retake it. That would be too easy. Uh, so anyway, so we'll talk a little bit more about that after I've gotten some stuff put together on Canvas. Um, and then we'll be doing the projects uh, as we go. So yeah, so that's sort of the rough plan for the remainder of the semester. Um, so the other thing I wanted to ask you guys about is, well, first off, how many of you guys have ever used Scratch before in school? Okay, I think I asked some of you, right? We've talked about this before. Do you guys remember what you did when you did Scratch? Like what kind of stuff you made? Like this is where you speak.
Oh, sure. Well, I actually wasn't really for class. I saw last semester. I saw someone like playing around with it
Hmm.
in class, and I was like, that looks like fun. So I just started making like a little thing.
Okay, so making like a little game, Cole, similar. Yeah. Okay. Um, right. So now my other question is, how many of you guys played Minecraft? Has anybody not played Minecraft in the crowd? Couple of you, but surely you've heard of Minecraft. Did you raise your hands for both that you both did and did not play? Are you Schrodinger's Minecraft player? No? Okay. Anyway, uh, so yeah, Minecraft. Um, so what we're gonna do? So we're gonna do two projects, one sort of smaller, one slightly bigger, with Scratch. And as it turns out, um, there are ways that you can do sort of Scratch-like programming that interfaces with Minecraft. So, how many of you would be interested in doing that? Okay, that looks like a big fat everybody, uh, except the guy who hasn't played Minecraft before. Why haven't you played Minecraft before?
I don't know. It was just none of my friends necessarily did. It was all Call of Duty stuff. So
Oh,
whatever.
well, I was gonna say, yeah, Minecraft, Call of Duty. Those are two rather different games there. So, yeah. Um, okay, well, we'll talk about that a little bit more, but in particular, there's two things I wanted to kind of show you guys today, which was um, make sure that the stream is actually live. Oops. Twitch moderator Prof McKinney. Yeah, so sorry guys, I didn't see the chat. Let's see. Jonathan, other Jonathan, Farden, Leon, or Lurks. How many of you guys, if you could type in the chat if you played Minecraft, and Claxjax, that's kind of a nice name there. If you did Minecraft when you were younger, s'il vous plaît. Okay, so there's two things about that that we can talk about. So the first is Scratch, right? So scratch.mit.edu. Okay. Um, now, so what I'd like you guys to do, if you haven't already, is make an account on Scratch and use your Wabash email address to do it. Yeah, question? Oh.
This computer sucks.
Oh. Well, sucks to suck, bro.
The Wi-Fi is just not working.
Oh. Well, yeah, and there was that network hiccup yesterday for like 5 minutes or something. That occasionally happens. Usually it's a squirrel decides to chew into a cable and get itself electrocuted, or some construction worker does something. So, okay, so yeah, make an account on Scratch with and just use your Wabash email address when you register. Um, you can make your username whatever you want, but please make it uh, G-rated, shall we say? Um, Needless to say, on my Discord server, I've gotten a couple of rather interesting usernames that I had to force them to change because they were rather inappropriate. So, yeah, so make an account here. And the reason I said to use your Wabash email, this part's kind of important, is in order for you to turn in an assignment, right? What you're really going to do is just share it on Scratch and then give me the link to your project. Well, you can't share a project unless you've verified your email address. And so after you guys finish putting in the username and stuff, doing your sign up, check your Wabash email, and you should have a thing from Scratch basically asking you to verify that you're not a robot, kind of thing. Okay. So, and it may take a minute to get there. It may also end up in your spam bucket. So just have a peek there just to make sure. Oh, we got all the RGB action going on over there. Yeah. And Mr. Razor, nice. If Apple made PCs, this is what they would look like.
Yeah.
Basically. Um, so, all right. Right. So make an account. Get it going. Okay. Let's see. We got Claxjack still plays Minecraft religiously. Yeah. Okay. Well, so I think what I'm going to do for you guys is um, the I'll give you a couple of options on one of the projects to either just do it in vanilla Scratch or do it in Minecraft. Okay, which would be kind of cool. Yeah. Um, okay, so while we're on the subject of that, and particularly if you've never played Minecraft before and you want to kind of get a taste of it, um, so well, better late than never, gentlemen. My goodness, what's y'all's excuse? All three of you? What, were you having a big cuddle fest? All right, how many of you guys used? Wow, pourquoi vous êtes plus tard? Parce que vous avez dormi longtemps? Ah, là là. La même raison. Okay, so for those of you who are so rudely interrupted class by coming in 12 minutes late, how many of you guys played Minecraft or play still Minecraft? Do you guys play? Yes? Never, have you ever played it before? Okay. Yeah. Alex, have you or do you play Minecraft? Do you know what it is? Minecraft? Yeah, okay. All right. So, um Minecraft turns out there's an education edition that you guys can download free. Okay. So, you download it and then you have to sign into it, but you sign in with your Wabash email address, and it uses the single sign-on system, right? So we have like a Office 365 license at the college, and this is sort of included in it, right? Normally it's like, all right, you get Word and Excel and Outlook, and oh, by the way, Minecraft Education, and yeah. So you guys can download this, the educational edition, and if you want to do some of the programming stuff, that's the version that we'll use, just because it's sort of set up, uh, and there's another piece of software that you'll need to download, but I'll put some instructions up on Canvas. So if you're interested in doing some programming with Minecraft, or just want to see what Minecraft is all about, then go for it and throw that on your computer. Um, and that one you don't have to make an account. You just when you fire up the game, the first thing it'll do is ask you to sign in. So yeah. Anyway, okay, cool. So let's talk about Scratch. For now, so let me just start creating something. Uh, there's plenty of tutorials built into Scratch, so if you've never done Scratch before, um, it's not too hard to kind of get into. And we've looked at it a little bit um, when we were talking about conditionals and iterative expressions and things like that, mostly just because I wanted you guys to see that uh, different programming languages all need to have some of the same fundamental units, right? Loops of some sort, conditionals of some sort, etc. How they look in each language and exactly what the syntax is and stuff like that, that's going to vary from language to language. Many of them look similar, right? So, like C++ and Java, you almost can't even tell the difference. Python, similar, but it just is missing the curly braces. Scratch is set up as more of a graphical language, and it does so because, well, that's good for children, right? Or novice programmers who have never done computer programming. You hand C++ to a 10-year-old, and it's not going to be pretty. Well, most 10-year-olds, right? One out of 100 10-year-olds would be like, sweet. And then suddenly you'd have Roller Coaster Tycoon or something. Anyway, what are the different things down the left? That's basically our palette of different categories of simple pieces, right? So we've got things that involve motion, things that involve looks, things that involve sound, events, which we'll talk about more later, control, which is when I say control or they say control, really they mean flow control. So that means like how the program is executing. So this is where your like conditionals, if thens, looping, that sort of stuff is going to be. Sensing, um, which is, checking things like, well, for example, if so Scratch is designed to be programmed and used for a computer, and so there's going to be you need to have input from the computer. Is the mouse clicked? Have you hit a particular button on the keyboard, etc. Right? And so that's all in the sensing stuff, along with a few other options. Operators, this is where basically all your math and logic stuff is going to be. So you can do arithmetic, You can have random numbers. You can check inequalities. You can do logic. So you've got and, or, and not. Where's NAND or on there? Or XOR? I don't see it. Why not? It'd be nice if it was there. Well, they fit inside each other. Uh, and and so what in terms of how Scratch is set up, but what that means is, well, what was the definition of XOR? A or B and not A and B, right? Okay, so A or B, but not both, right? Well, we can combine and, or, and not to get that logical statement. Okay, so and, or, and not, if you have all three of them, then that's sufficient to build up all of the other logical operations. So if you found yourself needing an XOR, well, you're going to have to build it. Okay, similar with NAND and other stuff. Okay. Um, all right. So, and then underneath that, we've got these four things deal with strings of characters. So, which is how you build up words and stuff. So, or arrays of things. Um, you've got modular arithmetic, which, what's the point of modular arithmetic? How many of you guys have seen mod? Is anybody in Math 108 this semester? No? All right, so the mod operator does stuff like, well, what's 17 mod 2? 1. Okay, why 1? It's the remainder. Okay, so this is something about math that I think is really quite criminal. So think back to elementary school when you guys first learned division. Okay, like third, fourth grade, something like that. Well, what did you do if the teacher asked, okay, what's 7 divided by 2? You would say 3, remainder 1, right? Then you got into middle school, and what did they tell you about the remainder? Not to do it anymore. Okay, and then you get to college, and guess what we tell you? Do it again. The remainder is actually the important part to some extent, right? So yeah, I think that's kind of funny, but um, what you can do with this, for example, is how do you tell if a number is odd or even? Well, if you do it mod 2, what do you get? You either get 0 if it's even or 1 if it's odd. Okay, so you can use the modular operator for that sort of thing. You can round numbers, and then you've got, if you ever needed them for some reason, you do have the advanced math block that will allow you to do absolute value, floor, and ceiling. Um, so what's the difference, by the way, between round and floor? Or ceiling, for that matter? Any ideas? Okay, so floor is a round, but it always rounds down. Ceiling is a round, but it always rounds up. And round, well, what's the rule about rounding? Just sort of, if it's 0.5 or bigger, you round up. If it's less than that, you round down. You sort of split the difference. Okay, well, if for some reason you always want to round up or always round down, then you've got floor and ceiling to do that. What else do we have in here? Square root, that's nice. Trig functions, oh joy. Um, huh? PTSD. Inverse trig functions, and then logarithms and exponentials, right? So you pretty much got any math that you could possibly need to do here, okay? Yes, but I doubt very seriously any of you guys are going to need trigonometry, so sorry. Okay, cool. Variables, you can create variables. We'll talk more about those in quite a bit. And then you can condense pieces of code into what they call a my block. That's kind of like a function, but yeah. Okay. Now, the way Scratch is set up, sort of as a concept, is, I would argue that to some extent it's object-oriented. Okay, so what that means is, or at least in the context here of Scratch, when you create something in Scratch, okay, this is the default project. What do I have? I have a background. I also have this sprite, which is what basically just an object is. And graphically, this particular sprite is represented with this cheesy little cat. Okay, fine. Well, let me make another sprite. Just doesn't matter what it is. And I'm just going to have it surprise me. Okay, so the other sprite it made is this character, Andy. Okay, whatever. Um, so one of the things that's sort of interesting about Scratch is that each sprite can independently have its own pieces of code. Okay, so if, for example, I did something silly like events when green flag checked, that means basically that the user has told the program to run. I could say, um, uh, say hello, but then for the cat, what I could do is I could say when green flag checked, say, oops, meow. Okay, and you'll notice that the code for these two things is the code associated with the cat is sort of inside the cat's object, and that for Andy is similarly contained within that. Okay, um, and if I execute this program, then both things are going to happen. All right, so if I run it, right, okay, they say hello or meow. The backdrop also, if I click on that, it can have its own set of code. Um, but does it make sense for the backdrop to have motion? Huh? Well, okay. So when you say that, what do you mean? Oh, yes. Okay. You can't do that with the backdrop. You'd have to do it with Sprite. Yeah. No, fair point. So Ethan's point was, well, what about if you were doing like a side-scrolling game where you might have the backdrop scroll? You in Scratch anyway, you couldn't do it with the backdrop. You'd have to have some other object that scrolled. Um, yeah. Uh, but okay. So the backdrop can also have its own set of code. So this is the to the extent that I would argue that Scratch is object oriented because each object can have code associated just with it. Okay, now this does, however, can get you into trouble. Okay, by which I mean when I hit the green flag, it appeared that those two things happened simultaneously. Both characters said something. Yeah? Is that really what happened? Well, it appeared to you as a human, but did those two things run exactly at the same time on my computer? No, they did not. Okay, so the downside to the way that they've set this up is it can sort of deceive you as the programmer to think that you're doing parallel programming when you're in fact not. Okay, so what does parallel programming mean? Um, Parallel programming means when you have, um, well, okay, let me back up a minute. So all of your computers, iPads and stuff included, right? What kind of processors are in them? Huh? Yeah. Who made them? Yeah, Intel or AMD. If it's your tablet or your phone, or maybe you have a Chromebook, then it's possibly also a ARM architecture processor. ARM doesn't fabricate any of their own stuff. They basically license the intellectual property to you, and then you can get it fabricated by a company that does just fabrication. So, for example, TSMC, Taiwan Semiconductor Manufacturing Corporation, they do a lot of fabrication for Apple, for example. So Apple designs a chip or a bunch of chips, right? And they send the schematics to TSMC, okay, and then they make them. And then Apple gets the big pile of finished products. They send them to their other factory, and then the people assemble them into iPads and whatnot. Okay. Um, but point being, you've got processors made by a few different people. But what about the processors themselves? So if you go and you wanted to go buy a laptop today, what what can you say about your processors? Yeah? Yeah. Okay. So what does that mean? How many cores? Basically, yeah. So in the, well, up until the late 90s, okay, a processor was exactly one core, okay? And these cores got bigger and bigger and bigger and more advanced and faster and so on. And then uh, we started to hit sort of a wall. So in terms of manufacturing ability. So what started to happen was said, okay, instead, we're going to make not just one gargantuan core, but several slightly smaller cores that each can independently operate to some extent. Okay. So the first processors that were able to do this were dual core. Um, so multi-core processors have existed for a long time in like servers and other specialized industries, but it wasn't until the early 2000s that this started to become a thing for the consumer. Um, okay, so what that means is that your computer is capable of doing two or four or whatever completely independent things simultaneously. It's as if your computer literally has four processors or two or eight or whatever. Okay, um, Scratch is not like that, but it makes you sort of think that it is. Okay, so if you have a really, really big, complicated Scratch project, it sometimes weird things happen, and it's because you think they're happening simultaneously when in fact they're not. Okay, so what Scratch is doing on the back end here is it's saying, okay, I've got three objects. I've got a cat, I've got Andy, and I've got the background. Um, and I'm going to execute whatever's in them, but I'm going to do it like, okay, start whatever a sprite is doing, start whatever Sandy's doing, start whatever the backdrop's doing. But that happens so quickly that you can't tell the difference between it happening simultaneously or rapidly in sequence. Okay. Um, all right. So um, now it would be nice if these things happened independently. They don't. But the real challenge that you have if you have things that are operating independently is how do you keep them synchronized, right? So if you are writing a paper and listening to Spotify, does it really matter if those things are quote synchronized? No, they have nothing whatsoever to do with each other. Okay. But what happens if you're doing something like image processing? So, like, let's say you took 1,000 photographs and you want to um, uh, run them all through Photoshop to give them like make them black and white or something. I don't know. Okay. You could set up Photoshop to do batch processing. Well, in that case, what would be a good idea? Let's say you got a 4-core processor and 1,000 photos. Yeah, do 4 at a time. Have each core deal with one file at a time, and photo number 1 and photo number 2 have nothing whatsoever to do with each other, so that'll work. Okay. Um, Another way to do it is you have each core do 1/4 of the picture. So you sort of speaking is hard today. Split the picture into 4 pieces and have each core do each one independently, and then you put the results together and move on to the next photo. I'm not actually sure which way Photoshop would do it, but theoretically you could go either way there. Okay, so, but that's not happening in Scratch, even though it might seem like it is. Okay, good. All right, so so what kind of stuff can we do here? We can do all kinds of stuff. You can make games. You can make um, little movies and things like that. Okay, so that's the first thing I'm going to have you guys do is basically make a short little like animation sequence. Okay, and so the motivation behind that is as follows. If we go to YouTube, right? So I'm just going to pick this one for sake of demonstration. All right, you guys didn't hear the sound, but there was sound there. Right, so you fire up a game, and what happens? Huh? Yeah, you got the developer intro or intros. It's sort of like in Hollywood, right? You watch a movie, and Paramount has the thing where the stars are flying, and then they make the little uh, arc, right? Or Disney has the thing with the castle and the magic rainbow thing, whatever. So you can make simple things like that in Scratch. So let's go back to Scratch here. Um, yeah. Okay. So basically, what I'd like you guys to do over the weekend is just kind of poke around in Scratch and just start experimenting. Okay. You're not necessarily trying to do anything. Just mess around with it, right? And see kind of what's there, what what art is built in, what sounds are built in, kind of, and think about, well, all right, if I had to make a simple little like 10-second animation, what kind of things might I use? What kind of things might I want to, what sort of style might I want to use? Okay. Okay. Uh, let's see. So let's talk more about some of the details here. So let me take my sprite, my cat, okay? And you'll notice up here at the top, I've got code, costumes, and sounds. Um, that's interesting. Oh, I wonder if it's because I'm running Safari. But do you guys click on the sounds tab? Is anybody using Chrome? Does it give that same error? Okay, so it must just be Safari. That is yet reason number 597 not to use Safari. Um, all right, anyway, but let me go to costumes here. So each sprite, okay, so sprite is an object. The costume is how that object looks. And what you can do is if you have multiple costumes, you can sort of animate a figure. And when I say animate, I mean that like in the old school like Disney cartoon kind of way. Right? So what is a cartoon or an animated cartoon from like let's take some old school ones like um did you guys watch Bugs Bunny when you were kids? Yeah. Right. So how is Bugs Bunny or any of those sorts of cartoons, how are those actually animated? Yeah, they're drawings, right? But what you're seeing is 15 of them a second or 30 of them a second or something like that, right? So it's sort of really, 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 really fast stop motion. Um, and there's no reason that that has to be drawing. So what about Wallace and Gromit? You guys seen that, right? So how is that made? Yeah, it's claymation, meaning that they make the objects out of clay, they position them, then they take a picture, then they make a very slight change to them, and they take a picture, and then another very slight change, and they take a picture. And if you put all of those pictures together and you play them really fast, then it looks like the clay is animating, right? Now, as you can imagine, this is an absolute crap ton of work to do that. Okay, so, well, to do it in the sort of professional way. So what you can do here is if you have multiple costumes, you can give the illusion of an animated figure. So in this case, the cat comes with two pre-built looks, and if you alternated between these, you can make it look like the cat was walking or running. Okay, um, and if we go to where did Andy go? Oh, it's because I need to go to. Did I delete Andy? Oh yeah. Okay. Well, now we got a penguin. Yeah, it's cooler. Womp womp. All right, so let's go to the costumes. All right, so same thing. Uh, it came with three different costumes. So here, if I alternated between all three of them, it would look like my penguin is, kind of doing the waddle thingamajig. Okay. Um, so now the costumes don't have to all look the same, right? How they look is up to you, but this is how you can do animated kind of figures is by switching back and forth between different costumes. And each sprite gets its own little bank of costumes. Okay, so the cat has his costumes, the penguin has his costumes, and so on. The sounds we've already seen. There's an error there, but each object, each sprite has its own little bank of sounds. So you can have like the meow associated with the cat, and uh, I don't know, some other sound associated with something else. Um, okay. Um, so let me sign in here and show you guys some stuff. Let's see. So it's oh, right. Okay, so I at one point set up my Scratch in French just for giggles, um, and so yeah. Um, okay, so the reason I wanted to log in was to kind of just show you um, a couple of let's see, couple of things that you can do here. Um, so like here we go. This one was a fun one. Okay, so I made a little game called Poof Clickers. It's not finished. It's kind of stupid. Any guesses as to what my inspiration for this game was? Huh? Well, yeah, South Park, but like, what game was I riffing on here? How many of you guys have played Cookie Clickers?
Oh yes, that
Yes?
was the game in seventh, sixth grade.
Yeah, exactly. Now, how many of you guys have never heard of Cookie Clickers? Um, right. So this is like one of the world's silliest games, right? So Cookie Clickers. So how does this work? I click the cookie and I get cookies, but then I can spend cookies to get things that automatically click the cookie for me. Oh yeah,
Yeah. And then
right.
if you, and then there's the one that make it rain, and people use assistive touch to be able to tap the swipe instead of
Oh, that's clever,
touching.
right? So okay, then after I have enough cookies, I could spend 100 of them, right? So now I'm automatically generating half a cookie per second plus whatever I do for my clicking, right? And you'll notice that the cursors get more expensive the more of them you buy. But once I've got 100 cookies, I can buy my first grandma who automatically bakes cookies at 1 per second, right? And then we can keep this up for a while, right? And eventually I can have a cookie farm that will raise cookies out of the ground, because that's totally how that works. Right. Okay, so what's the point of this game? There isn't one, right? It started kind of as a joke and then went nuts. So, all right, so let's go back to Poof Clickers. So this is what uh, I wanted to riff off Cookie Clickers. So what does it do? Right, so you click on the bowl of cheesy poofs, and then so now I have 15 poofs, and my mom price, so I can buy a Mrs. Cartman. All right, and now I bought two Mrs. Cartmans, and they generate 5 poofs per second. All right, well now I can buy more Elaine Cartmans, right? And I'm getting 20 cookies per second, but the poof price or the mom price has gone up, right? And what I was going to do was put like I was going to have multiple characters, so like after Cartman's mom, you could get like Timmy and um, oh, I don't know, Chef maybe or something like that to generate more things. Okay, so the stupidest possible game, right? But what I want to look at is sort of how did I program this thing, okay, and uh, how do I do all of this in this relatively simple looking language? Well, um, let's look inside at the code. Okay. Let me put this not in French for you guys. Um, Here it is. Is that better? Okay, I've got a whole bunch of things in there. All right. Um, all right. So, what are the different sprites that I have here? Well, I need my bowl of cheese poofs, my Cartman's mom. I also put the little heart in there, so like just to make it look cool. When you put your mouse and you hover over Cartman's mom, then the heart appears. And if the mouse isn't over Cartman's mom, then the heart disappears. I've also got the display of three variables: the number of poofs, the number of moms, and the number of or the price per mom. Okay. Um, and then I've got a backdrop, which in this case is just the thing. Okay, so um, right now we're looking at the cheese poofs. Okay, so when you start the game, it sets the size of the bowl of cheesy poofs to 200%. That's just to make it look nice. That's all. I also imported the bowl of cheesy poofs. I just found an image on Google somewhere and then loaded that in. So you can do custom art here. Um, Same thing with the Cartman's mom. That's all I did was took an image off of that I found on Google, clipped it to be the size that I wanted, and then went on. Okay. The other thing that happens is, well, there's an event. If I click on the sprite, then I want to do something. Okay. So what do I want to do? If I click on the bowl of cheesy poofs, I want to increase the number of poofs by 1. I made it set size to 220, wait a tenth of a second, and then set size back to 200. So what did that do visually? Yeah, it made it seem like it popped a little bit, right? And again, I was riffing off of the cookie clicker game here, just for sake of demonstration. And that's it for the cheesy poofs. Okay. All right. What about the Lane Cartman or Leanne or whatever, Mrs. Cartman? All right. That's where most of the code is. Okay. So, um, so what am I going to do? Well, when I start the game, I need to say, all right, is the mouse over Mrs. Cartman? Not clicking, but just over that sprite. If yes, I send a message to the heart that basically tells it, hey, make yourself visible. And if not, I send a message to the heart that says, hey, make yourself invisible. And we'll talk a lot about messaging next week. Okay. And then when the game starts, how many moms should I have? Should have no moms, and the mom price should be the base amount, which I just made 5 for the sake of demonstration. Okay, so look at the rest of this. If poofs is greater than mom price minus 1, meaning that um, you have more poofs than moms, okay? Or sorry, not more poofs than moms, but you can afford a mom. Then what does Lane Cartman do? You saw how she kind of glowed a little bit, yeah. Okay, so I did that. Set the brightness effect, and then if mouse down and touching mouse pointer says, okay, is the mouse touching Cartman's mom? Yes or no? Possibly. Is the mouse being clicked right now? Yes or no? Okay, so when I say now, I don't mean right this instant, right with me standing here, but like the mouse is either being clicked or it's not, and the mouse cursor is either over that object or it's not. If both of them are true, that the mouse is over Mrs. Cartman and being clicked, that means that I'm clicking on Mrs. Cartman, right? And what do I want to have happen under that circumstance? I want to buy a mom. Okay, well, I want to buy a mom. Okay, so I change the number of moms by 1. I increase the number of moms, but I have to pay for the mom. So I need to deduct the appropriate amount of poofs from my poof account. And then, because this is the way it worked in Cookie Clickers, what happens when you buy an object in Cookie Clickers? If you want, like, let's say you buy a grandma, what happens? How much does the grandma cost to start? 100 cookies. How much is the second grandma? It's more than 100. Okay, so the price increases the more of them that you have, okay, which is part of the game mechanic. And so what I did there is I said, okay, change the mom price by, and then I just made up some sort of exponential formula so that the mom prices gets steeper, the rate of increase um, of the price gets steeper and steeper and steeper the more moms you've got, okay, like it is in Cookie Clicker. Okay, and then well, there you go, right? And then there's some other stuff down there below. Okay, so what we'll do next week is we'll start to just make up something to make, and we'll just start making it. Okay, and that'll kind of show you guys the process. So, what is your assignment this weekend? Play around with it. Okay, the other part of the assignment, I guess, would be if you are interested in doing your second project involving Minecraft, download the Minecraft Educational Edition. If you've never played Minecraft before, same thing. Mess around with it. Okay, find a buddy who's an expert in Minecraft and get kind of things figured out. Okay? All right. See you guys on Monday.